Did you know there's a floating island of plastic waste that's over 2,000 times the size of Singapore? This massive scattered collection of debris is known as the Great Pacific Garbage Patch, or GPGP. Located between Hawaii and California, it covers an estimated area of 1.6 million square kilometers. The GPGP is formed by powerful ocean currents that create large swirling vortexes known as gyres. These gyres are systems of circular ocean currents driven by Earth's wind patterns and the forces from its rotation. These currents pull in debris from across the Pacific, trapping them in a dense floating patch. The GPGP also contains microplastics that affect marine life and disrupts ecosystems. Now that we understand what the GPGP is, let's take a closer look at the core issue. The GPGP is the Pacific Trash Vortex, describing the swirling mass of debris collected by ocean currents. With around 1.8 trillion pieces of debris, it holds an estimated 100 million kilograms of discarded items. Larger items like abandoned fishing net traps harm marine life, from seabirds to sea turtles. Microplastics and toxic chemicals spread through the ocean, contaminating the food chain, and eventually, this contamination ends up on our plates. The GPGP drifts in international waters, where most of the waste coming from nations like China, Japan, South Korea, and the United States. Yet these countries have not taken responsibility, allowing the problem to grow. Without collective action, the patch will continue to expand. Now, let's bring this issue closer to home.
From 2013 to 2023, there has been an overall decrease in the amount of waste generated per day domestically. However, the decrease in the last 10 years has been inconsistent. In 2023, the amount of waste generated per day was approximately 0.88 kg, which might seem like a small number, but we must not forget that this only represents the waste generated per day. And if we look at the total amount of waste generated per year in 2023 alone, both the domestic and non-domestic sectors accumulate around 6.86 million tons of waste, which is a huge number. With huge amount of waste generated yearly, it will not take long before Singapore's one and only landfill reaches its full capacity. Currently, more than half of the landfill, which is divided into two sections, is now full. As a result, the need for Singapore to redefine its waste management strategies has increased, and not just at the household level, but also at the industrial level. As an example, let's look at China's ban on single-use plastics. This project has a 5-year timeline from 2020 to 2025, where China aims to establish a global standard for banning single-use plastics completely, and develop a cutting-edge recycling sector that will influence other countries to do the same. In the context of Singapore, a 5-cent fee has been implemented in supermarkets for every disposable plastic bag consumers use. Unlike China, Singapore does not ban the use of plastics completely, but encourages reducing consumption through repurposing. However, the extra charge is not enough to raise public awareness about waste management, as most people bring their bags not because they understand the importance, but because they do not want to pay extra.
Currently, a conveyor belt system is used in Singapore's waste sorting facilities. These processes often require the waste to be physically sorted. These inefficient sorting methods, coupled with the poor public awareness and contribution, resulted in a majority of plastic waste to end up in the waste field. One possible innovative solution to tackle this issue could be the implementation of AI image recognition and machine learning technologies. These technologies can fully automate the waste sorting process. A robotic arm can be used to physically separate these waste materials into different categories. The 5 main categories are recyclables, hazardous waste, organic waste, electronic waste, and other general waste. After being separated, the recyclable materials will go through an infrared spectroscopy scan. This system utilizes infrared light to obtain information on the molecular vibration and absorption of energy by the waste material, hence identifying the materials and its composition. With predetermined data, the AI will then be able to sort the waste based on the materials. Plastic can also be further sorted into the different types of plastic and be sent for further processing and treatment before recycling.
From the Great Pacific Garbage Patch to our shores in Singapore, plastic waste is a global issue we cannot ignore. And with no single country taking responsibility for cleaning up, the patch keeps on expanding, affecting not only us but also marine life. Therefore, it's critical that we start accepting accountability for our actions now. To reduce plastic waste, we can use simple actions like using reusable bottles, bags, avoiding single-use plastic products, and supporting recycling initiatives. It's crucial to educate ourselves and raise awareness about the problem, as disregarding it can hinder our daily lives.